Hello! Today we are going to be asking ourselves one of the key questions in most algebra classes: is something a function? To be more precise, we are asking, is a relation a function? And as you can see on the screen here, any relation is a function if every input in the relation matches to one and only one output. Now, relations can be expressed in a number of different ways. In this video, we will be studying tables, mapping diagrams, ordered pairs, and graphs. The question here is, how can we take this definition for function and apply it to all of these different types of relations? Well, I suggest you take a close look at your screens. If you want to know whether a relation written as a table is a function, then you need to look to see if there are any repeats in the x column. If two of your x values are the same, then your relation is not a function. For mapping diagrams, you just want to make sure that none of the inputs has more than one arrow coming from it. If you have an input that has more than one arrow coming from it, guess what? It's not a function. For ordered pairs, also known as points, we are again going to look for any repeat x values. That would be the first value in any of your points. Should you have an x value show up more than once, guess what? It's not a function. And finally, for graphs, we will use the vertical line test. The vertical line test says that if you can draw a vertical line that passes through your graph more than once, guess what? It's not a function. Remember, for each of these representations, this is how we're going to determine if every input has exactly one output. Let's go ahead and take a look at some examples to see how it all shakes out. Our first set of examples asks us to take a look at some relations that are tables and determine if they are indeed functions. Remember, the rule says that no repeated x values are allowed. So this table right here, which has 1 show up 2 times in the x column, is not a function. No, it is not. Repeated x values are bad. And once again, in our next example here, we're going to look for repeated x values, and as you can see from this table, every single one of them is unique. -1, 2, 4, 8, and 9. Since there are no repeats, this is indeed a function. Great, so hopefully we understand tables. Let's take a look at a different kind of relation. Our next type of relations are mapping diagrams, and for these, we're looking to make sure that every input only has one arrow coming from it. In our first example here, we see that the number 1 maps onto 12, 2 maps to 13, 4 goes to 7, 5 goes to 3, and 9 goes to 13. Since there's only one arrow coming from each of these, this mapping diagram does indeed represent a function. Let's see if this holds up in mapping diagram number 2, diagram B. We see 0, in this case, goes over to 5, 3 goes to 0, and 3 goes to something else. We see 2 arrows coming from this 3, which means that we have one input that goes to 2 outputs, which means it is not a function. So, this is mapping diagrams. Let's see what happens when we have sets of ordered pairs. For points, we want to make sure that no x value is repeated. In relation A, we have 1, 2, 4, and 8 as our x values. Since there are no repeats in this, we say that yes, relation A is a function. How about relation B? We have 0, -1, and repeated zeros here. In the third point and in the first point, we have the same x value, which tells us that no, relation B is not a function. Nothing to it here, folks. Let's go ahead and take a look at what happens when our relations are expressed as graphs. To tell if a graph represents a function, we perform the vertical line test, which says if you can draw any vertical line that passes through your curve more than once, then it's not a function. In our first graph here, we can see that yes, indeed, we can draw a vertical line that passes through more than once. Take this one, for example. It passes through here and also here. Therefore, we fail the vertical line test, which says no, this graph is not a function. In the red graph, we'll see if we can do the same thing, but interesting. It doesn't look like there's any place where we can draw a vertical line that will pass through more than once. We can even take this line and drag it along the curve here, and as you can see, nope, everywhere we seem to be going, it only passes through the one time. In this case, we can just say that the point of intersection is here. Since we couldn't find a spot where we could put our vertical line through more than once, we passed the test, and this is a function. Fantastic! So hopefully what you've taken away from this is that it doesn't really matter which way a relation is represented. None of these tests for functionhood are particularly difficult. In fact, very few of them require any action on your part at all. You're just looking to prove that every input has exactly one and only one output. Or, on the flip side, you're trying to show that there is an input that has more than one output, which would disqualify your relation from being a function. For more specifics, go back to the beginning of the video and take notes on that section, or watch any of the examples over again. That's all for now. Thanks for coming, and toodaloo.